And hello everyone. Hello? Yes, okay, so the thing's working. Anyway, so right, the mic's working and welcome to this video on OpenFOAM. In the last video, we have talked about changing some of the turbulence properties to Reynolds average stress, so RAS. And I think in the last video, when we were copying some of the things down, there was a letter S that was missing when we copied over the simulation type. So I have to change it in this video. Alright, so this is in your turbulence properties. And let's look at transport properties to see whether anything else went wrong. Okay. QA. Clear. BI transport properties. Okay, nothing there. Let's quit this. Okay. Let's go to 0.original, see whether there's any file missing. Okay. Doesn't look like it. Alright, so pretty much we are almost ready for a dry run. Okay, so let's see whether we did our FV schemes copying over correctly. Yep, no letters missing. All the 5K, epsilon, everything is there. Try and turn that sound off. Yeah, so next step. Okay, we'll want to edit, we want to edit our files, at least the boundary conditions and the control tick, because we want to simulate a faster flow, which is of course going to be turbulent. All right. Anyway, but before that, we'll just want to run a dry run of the cavity file. Okay, so let's take a look, see whether doing a block mesh, and then we'll run a pisoFoam. So you'll just run a pisoFoam, and these are the standard, ways of doing just running pisoFoam. So now the pisoFoam has finished, and let's see whether the data is out. So yes, the data is out. Very good. We can just port it all clean over. All right. So I'm going to copy all this over. I'm going to VI all clean. Insert. Insert and paste here. So yeah. Instead of clean case 0, I'm just going to do clean case. So chmod all clean 755 for it. I can't remember how to do it properly, but okay. Alright, looks good. So I'm going to do all clean to clean the case there. And that's done. Yep, so works perfectly. Okay, so next step. Okay, we want to do a very quick run through, okay, of some of our, we want to change the boundary conditions, right? Oopsie. So never mind, we just press U. We are supposed to go. No, this was our previous speed, which was 0.0001, and that gave us a pretty low Reynolds number, enough to be laminar. So now we don't just want that. Okay, we want what do we want? We want at least the bottom patch to go with a speed of maybe 0.1, so that's about 1,000 times faster. That is confirmed a turbulent flow. Okay, so let's quit that. Let's see whether the mesh generation actually has potential foam in it. Oh, it does not have potential foam. So yeah, maybe there are two ways to go about this. We can run potential foam first. Okay, we can run potential foam first, or yeah, we can run potential foam first, then we start the thing, or we can just run it straight because there's no contraction or expansion of the pipe. We can just run a pisoFoam. Okay, ideally, of course, we can do a potential foam. So let me clear this up. Let's see whether we can incorporate the potential foam inside. Yeah, so yeah, there will be other things that we need to incorporate. So CD0, we'll need a 5 file. Okay, actually this is made by potential foam, so we don't really need that, I think. In the FV schemes and FV solutions, there should be some differences we'll need to spot if you want to include potential foam in. I think it's in FV. Oh man, you know what? Let's do this later. We'll just make a dry run of pisoFoam turbulent. Clear this up. Have a dry run of pisoFoam, the turbulent version, and then we'll try to include potential foam in this whole system to make it more a complete kind of thing. So yeah, we'll just do a mesh generation and then we'll do the run to get this thing going. Hopefully the current number will not be too high, but we'll need to do some changes anyhow. Let's take a look at the control dictionary, and since we increase the U velocity by 1000, we'll need to decrease the time step by 1000 likewise. So it was 25 seconds before. 25 divided by 1000 is 0, just to be sure. 25 over 1000, 0.00025. 0.025. Okay, 0.025 it is, and we'll save and write. Let's quit, and then we can start running our scripts to see whether the thing can run properly. So again, there's no physical correctness to this per se. We didn't check it for that, especially when we do the boundary conditions for, okay, we didn't do the proper correct boundary conditions for K and epsilon. So these are the only two things we need to take note of in this. All right, we'll need to change this to make it, physically representative of a real thing. But for now, we don't change it first. We just want to test the code, see whether it runs. So first thing first, mesh generation. Yep. So you'll do the mesh generation on that. And we have tested it before. It's pretty okay. It doesn't make the computer overload. So let's go use the other one and take a look at the potential foam. See whether there are anything we can copy over, right? We can put it in the run. So let's go to we can go to here. You can VI the run. So that's only icofoam there. VI mesh generation. Apparently I didn't put in the potential foam run directory. All right, whatever. Okay, so but anyway, there will be a potential foam that comes before the run, and let's take a look at the system. And, VI the FV solution, because there should be a phi entry here and a potential foam entry here. So this should enable us to run potential foam. Okay, so again, we're going to clear this. I mean, since we have time, right? We're going to run a potential foam on this thing first. So cd system vi. Oh wait, yes. I'll try and stay on task. Maybe next time we can do this when this thing runs finish. We can do a step-by-step comparison. Copy the relevant code over to incorporate potential foam into this into the running of this file. But for now, we skip it first and just let you know. Yeah, we can copy some things over later. Anyway, so we'll just do a dry run to see whether the current number. Oh, sorry. I want the n. Okay. I think I want to change something. Okay, so vi run. So log.pisoFoam, right? I'll just do this thing. rm-r log.pisoFoam, and I'll save it. That makes it easier next time. Oh. Okay. So anyway, we run into a very quick problem. I think I forgot to change the boundary conditions. So we'll have to change the boundary conditions. All right. All right. Let's take a look. vi 0.original. We'll need to change it from the vi 0.original. Okay. Okay. So again, I'll do this later. Yeah, of course the boundary field is wrong, obviously. So we'll need to do something about that. Okay, internal field, we don't really need to change anything. It's just the boundary field. Okay. So let's go to pisoFoam or turbulent. Okay, we go to 0.original. VIU. Okay, so the patches are called top patch, wall, and bottom patch. So we'll need to change the patch names to these. So let's go to epsilon first. Top patch, wall, and bottom patch. Okay, so neither of them they are empty. Okay, so these moving walls, these are for wall function. So top patch should be a 0 gradient. Okay, so let's see. And the bottom patch should also be a zero gradient. All right, bottom patch. So I'm gonna save this. Okay, that's done. And I'm gonna press the delete here to, yeah, I'm guessing it's a 0 gradient. So we know the spelling: top and capital P patch, bottom capital P patch, and yeah. So we'll just leave it as that. And let's look at K. Same thing. We change it to 0 gradient. This is top patch. Zero gradient. Value is the nothing. No need to have a value there. So wall with no caps. Bottom patch is here. Yeah, so if you look at the log files, we found that there are errors with these things, so that's why we need to change accordingly. So let's quit. So make sure it's done properly. Yes, it's done. Okay, vi new tilde. So again, these things can be all zero gradients. Okay, a bit tedious, but we gotta do what we gotta do. All right, so wall, bottom patch. Oh, and this should be a zero gradient as well. There's no empty because this is not 2D. Zero gradient. So nut, again, we look for all the zero gradients. The rest we just for this one we just leave it as it is. We notice that in the walls, this is the entry that's being used, so we'll keep it at this entry for the walls. Okay, so top patch. So this I will leave it as a zero gradient, and delete this line. This will be wall. And this is bottom patch. This should be a zero gradient. Okay. So last one will be omega. Okay, so walls are as such. So top patch, type zero gradient again. Delete wall, type is this, bottom patch, not empty but zero gradient. If in doubt, just leave it as zero gradient, because this is the most, well, can't do you much harm kind of a thing. Okay, so looks like everything is in order. So let's see whether this time it's able to run. So I'm going to do the run again. Let's see, vi log pisoFoam. Let's see what's wrong. Selecting incompressible transport model Newtonian, selecting RAS, selecting RAS model K epsilon. Foam warning. From function constant foam something something something. In file meshes polymesh. Remove patch group wall. Or patch 1, which has the same name. Okay, so looks like we got to start from the beginning. We'll try to do an all clean. Mesh generation. We're gonna do snapping X mesh. It's gonna take about a minute. I'm gonna fast forward this time. And now that that's done, let's see whether we can run this thing. Okay, run n. vi log.pisoFoam. Okay, so all looks okay as long as we start running from scratch. So look at this. The current number max is like 0.3, so that's a very safe thing. So we'll just let this thing run. So at least we show that the dry run running of this pisoFoam is possible, so long as we ensure that the inputs are correct within the constant and turbulent properties. So we just do a step-by-step, comparison to see what are the entries we need to put in to run pisoFoam properly. And yeah, perhaps in the next video we'll try and see what the results are for this simulation, and then if possible, can put in potential foam, and of course we can also discuss some of the theory in our next step, of course. All right, so that we can make sure the the thing is run properly, pisoFoams run properly, and you know that kind of makes sense. The parameters, the k and epsilon parameters that we enter in are correct. You have to find out some ways from literature to see whether it's correct. So thanks for watching. I'll see you guys next time. Hope you enjoy. Please leave a like and subscribe if you think this is useful and helpful. Thanks for watching.